All right, let's jump right into this explainer and unpack the mystery behind what is arguably the most famous structural silhouette in the world. When you picture the Parisian skyline, your mind instantly goes to the sweeping, elegant curves of the Eiffel Tower, right? But where did those curves actually come from? Today, we're completely tearing down the assumptions surrounding this monumental structure. We're going to look closely at a genuine historical mystery. We need to figure out whether the design of this 300-meter giant was dictated purely by the cold, hard physics of wind resistance, or if it was secretly guided by a hidden sense of beauty. It's a truly fascinating look at where hardcore engineering collides with public perception. So let's talk about that iconic silhouette. Our story actually kicks off back in 1884. But surprisingly, the original idea wasn't even born in the mind of Gustave Eiffel himself. Instead, two brilliant engineers working for his company, Maurice Koechlin and Émile Nouguier, were the ones who proposed an iron structure of just an unprecedented, massive scale. Now, if we trace the very first 1884 sketches of the tower all the way to its globally recognized final profile, you'll notice something amazing. That foundational concept, four massive curving legs bracing against each other and meeting at the top, was literally there right from the absolute start. And right here is where Alexander Gustave Eiffel steps onto the stage. The guy was already an absolute master of iron. In fact, he had just finished designing the internal supporting framework for the Statue of Liberty over in New York. He wasn't just a builder, though. He was a brilliantly savvy project champion. Recognizing the sheer genius of his engineer's proposal, Eiffel stepped in to passionately drive this colossal Parisian project, leveraging his massive reputation to make it a reality. But as you can imagine, building a lattice iron structure that was essentially twice the height of the world's tallest building at the time, that brought up a terrifying, invisible enemy, the wind. These guys were flying blind. The engineering team was venturing into completely uncharted territory. They desperately needed a way to ensure a 300-meter open lattice structure wouldn't simply be blown over. And making matters worse, the scientific community severely lacked data regarding extreme wind pressure at those dizzying heights. They were literally forced to rely on basic 18th century aerodynamic formulas created by John Smeaton. Looking at the actual structural plates from 1885, you can see the extreme caution Eiffel's team had to take. Without modern computers or wind tunnels, they created insanely complex graphic statics calculations. They were drawing intricate geometrical lines by hand just to mathematically map out the wind's potential destruction and figure out how to survive it. So, to solve this massive headache, and honestly, probably to calm down a very nervous public, Eiffel boldly came out with what he called his flawless structural principle. He claimed this rule alone dictated the entire shape of the tower. Basically, the idea was this. If you drew tangent lines at any specific height along those curved legs, those lines would intersect exactly at the center of the wind loads pushing from above. The theory was that by perfectly aligning the curve of the legs with the wind, the tower channeled all that invisible destructive force safely straight down into the ground, completely bypassing the need for extra heavy cross-bracing. When you put Eiffel's pure geometric theory, which is basically a diagram showing how angled legs perfectly balance horizontal wind forces, right next to Koechlin's actual 1884 graphic statics diagram calculating the wind's overturning moments, you really get a sense of the sheer audacity here. The goal was to map that theoretical mathematical perfection directly onto real-world iron. And Eiffel sold this to the public as absolute gospel. He essentially argued that the iconic curve of the tower was a non-negotiable outcome of physics. He was telling Paris, look, if you want a 300-meter tower that actually survives the wind, this is exactly what it has to look like. It sounds like a total triumph of pure reason, right? But let's put on our detective hats for a second. We have to audit their 1884 math and ask, did Eiffel's team actually follow their own unbreakable engineering law? Did the math really draw the tower? Well, when modern researchers meticulously dug into Koechlin's handwritten original 1884 calculations, the ones held safely in Zurich analyzing the forces on the lower legs, a pretty fascinating discrepancy started popping up. If we directly compare the initial tower they actually drew with the mathematical tower their wind calculations demanded, they don't match. At all. The physical shape they sketched out on paper was fundamentally different from the shape the wind equations were telling them to build. Just by plotting out the true measurements against Eiffel's supposed structural principle, a startling truth emerges. The mathematical ideal generated by the pure physics equations deviates significantly from the actual engineering drawing they decided to produce. To give you a real sense of scale here, we are talking about a glaring average difference of 1.9 meters between the mathematical ideal and the final silhouette. And up at the very top of the tower, it was off by a full 3 meters. They definitely weren't strictly following the formula. They were deliberately tweaking it. Which brings us to a huge realization. This was engineering functioning as public relations. The engineers purposefully manipulated the shape of the tower. So it begs the obvious question. Why on earth would Eiffel claim it was pure physics dictating the design when he knew full well they had bent the rules? Well, you have to remember the volatile context of Paris back in 1885. Eiffel was dealing with some brutal, intense public backlash. 47 of the city's most prominent artists and writers published a fierce protest, calling the proposed tower useless and monstrous. They were absolutely terrified that this massive, naked iron structure was going to entirely ruin the historic beauty of Paris. But Eiffel, he was a master at PR. He masterfully deflected all this artistic criticism by leaning hard into his structural principle. He asked this incredible rhetorical question. Isn't it true that the conditions of forces are always consistent with the secret conditions of harmony? He framed his beautiful sweeping curves as an immovable scientific necessity rather than an artistic choice. It was his genius way of saying, hey, don't blame me, the wind designed it. So ultimately, that supposedly rigid structural principle wasn't just about a physical framework. It was a brilliant piece of public relations. It justified an impossibly huge build, it completely masked their massive uncertainties about high-altitude wind, it neutralized the fierce aesthetic critics, and it successfully portrayed the entire design as an inevitable marvel of modern engineering. And honestly, even today, we see exactly this kind of strategic PR shaping the monumental projects of our modern era. It really makes you realize the Eiffel Tower is a masterpiece, for sure, but it's as much a masterpiece of narrative and spin as it is of iron. If the math was literally bent for the sake of beauty, does that make Eiffel an engineer or an artist? It definitely leaves you wondering just how many other rigid engineering marvels out there are hiding their own secret conditions of harmony. Thank you so much for joining me on this explainer. Keep questioning the structures around you, and I'll catch you on the next one.